So this is the last class. The sample final is out. But given that I'm getting a number of questions about Project 3, I think what I want to do is talk about Project 3 first, and then I'll go over the sample final, and I can always, the final exam is not until next Monday. You have a week. Plenty of time to cover that. So what I wanted to do was go through Project 3 and talk about some of the things with it, and then answer any questions people have. And hopefully I can clarify some of the things and figure out some of the issues that we had last week. So I'm presuming by now you've got Anaconda Navigator running, and you know how to start a Jupyter notebook. You can at least install, you can at least get a Jupyter notebook up and running. Here we go. This is what I have. And I don't have the markdown cells with the documentation, but of course, as you know, you have to write the comments, the documentation. So here is what is going on. As we've talked about before, you have to import the Pandas module, which comes with Anaconda Navigator. And I said just symbolically, we import it, we give it the variable name PD. PD stands for Pandas. Okay, and then we import Plot9 as well. That was one you had to install either using pip or conda or whatever. Okay. Now we're going to read in the data file. And again, this is my Mac, so this is the full path to the data file on my Mac. You will replace this with the full path to the data file on your computer, and when we grade it, we will replace it with the path to where we have the data file on the computer we grade it on. But this is just the full path to where it is on my Mac right now. It happens to be in Users, Alfred Arsenal, PyCharm projects, Fall 2020 project, Project 3.data. Fine. I read in the data frame with the read CSV command. This simply reads in the data frame. Now, as I've shown you in the next cell, just to check that it's there, I use the head command, which actually should have parentheses around it. And it shows me that I have, in fact, read in the data frame properly. So we're going to go ahead, and then again, the nice thing about Jupyter Notebooks is you can run each cell, but let's make sure you run them in order to make sure you're getting there, right? So we're going to run this cell to import. That works fine. Now, when we run this cell, we're going to read in the file into this data frame. Okay? And then we run this cell, and we see that we have the data frame read in properly. It looks good. This is the result of dataframe.head. Now, we're going to ignore this right now. Just ignore it. It's some debugging code I was writing, so I will delete it. I have the data frame in. This is what it looks like. Now, I want to convert it. Remember, I said in the instructions, from a Python Pandas data frame to a two-dimensional list. I do that with this command right here in this cell, dataframe.values.toList. We run that, that's fine. Now, we're going to have to change back to use Plot9. I'll get to that in a minute. Right now, we are working with a two-dimensional list. It's a standard Python two-dimensional list like you've been working with for half the semester now. Okay. What I want to do in the simplest case, or in the first case, I'm going to take only the Republicans out of this entire ginormous 2D list. I'm going to take only the Republicans, and I'm going to put them into a smaller 2D list. So, Republican is my new 2D list that I initialize here. At the same time, I'm only taking the Republicans. I'm getting rid of all of those other columns that I don't want. Remember, the columns that I don't want are the columns I do want are column 0, column 2, column 10, column 11, and column 14. These are given. So I create a list, and my list L is the columns I want. So what I'm going to do in this code is I'm going to take out the Republicans, and I'm going to copy for the Republicans only these columns. Okay. And so all it takes to do that, as we've worked with 2D lists all semester, all it takes to do that is this little nested loop. I'm going to go through every line in DF. DF is this two-dimensional list up here. Okay. If I want to see what DF looks like, I just put in a code cell, show me what DF looks like. It's this ginormous 2D list. Okay. Now I'm going to delete that cell because I don't need it. So with these constants defined and our initialized list, this nested loop is all I need to take only the Republicans out and only the columns that I care about. So let's run this cell and make sure I didn't make an error. Okay, it works. Now what I'm going to do, I have the 2D list called Republican. So let me insert, just for debugging purposes, a new cell, and let's see what that two-dimensional list looks like. Okay, and here we can see, whoops, it only has the columns I care about: year, state, candidate, party, votes. And it has all the Republicans. There are no Democrats or anybody else. So that is how I've tested that little, get rid of that cell. This little loop right here was enough to give me the Republicans. Now, for step, I think it's 11, 10 or 11, whichever one it is, in the assignment, you have to get the Republicans, the Democrats, and the two people by name. Okay? So all you have to do to get the Democrats is add an or and check to see if the party's equal to Democrat there. And then you have to add other clauses that said if the name is Bernie Sanders or if the name is Angus King. That's fine. Either way, this is the two-dimensional list you're going to wind up with. Now, I told you in an announcement last week, and I need to clarify this again, Plot9 works best with data frames, with Pandas data frames. It's written to do it natively. To get Plot9 to work with standard vanilla Python 2D lists is a royal pain in the neck. So I told you last time, and I want to go through this again, before you do your graphs, you are permitted to migrate back, to convert back from a 2D list into a data frame. So this Republican is a 2D list, and we just showed you, we just printed it out to show you what it looks like. How do I convert that back to a Pandas data frame? It's this statement right here. PD, because I'm using this Pandas, this says data frame. Convert this list Republican from this cell, convert it into a Pandas data frame. Now, in Pandas, the advantage to data frame is all the columns have names and you can assign them and manage them with names. Now, the default is if you do not tell Pandas, if you do not, in this data frame statement, if you do not assign column names, you get digits. You get 0, 1, 2, 3, 4, 5, 6, etc. That's the default. You can tell it what to use with these. So you could do it one of two ways. In this statement, I have said, convert my 2D list Republican from the previous cell into a data frame and assign the columns headings in order: year, state, candidate, party, votes. That gives me column headings. This is one way of doing it. We will run it. Sorry, it jumped down on me. Okay, this cell ran. Okay, another way to do the same thing would be to do this. Another way to do the conversion, and this is perfectly valid, is I could say, I'm going to call it rep 2, so I don't mess myself up. Okay, that statement by itself says give me a data frame, and now I'm going to assign column headings. And now I can put this list in, and I'll just copy that in here. Because if I type it, I'm going to make a typo, and I just save time. Yeah, we don't need 2 square brackets. Okay, either this cell or this cell, these are 2 equivalent ways of doing the same thing. Either way, either by doing this way or by doing these 2 lines together, you now have a data frame, okay, with the appropriate column headings. If you want to see that for sure, we're going to come back to here. And let's take a look at it. And you can see this is the data frame we have created with this statement. You could run these 2 as well and get an equivalent one. You can see we have a data frame. Because it's a data frame, Pandas is automatically inserting the row numbers. We don't have to worry about that. But we have the column, the year, the state, the candidate, the party, the votes. Now, to do step 11, I want to create my bar chart of votes for Republicans total. I want to get fancy. I'm not going to get fancy. Get rid of that one first. Come back and reinsert that later. It looks like this. I want to make sure I have all of my variables and all my methods and functions known. So to play it safe, I'm going to re-import from plot9 the ggplot method, I'll fix this. I want to re-import ggplot because I'm going to use that. geom_col. Now I mentioned geom_col and geom_bar. You can produce bar charts or histograms with both geom_bar and geom_col. geom_col is a little better, gives you a little bit more flexibility. And I'm going to import the aesthetic. So I need to make sure I import these. If you give the next command I'm going to show you and you get we don't recognize this is missing, then you just need to re-import it and it's here. Now, the default is as follows. We need a ggplot object, okay? And the ggplot object is going to be created from dfrep, data frame version of Republicans. That is what I created right here. dfrep was created right here. It looks like this data frame right here. I want to take this and I want to create a ggplot object. Now, the aesthetic, I'm going to use geom_col to make it a bar chart, a histogram. The aesthetic, on the x-axis, I want the year. On the y-axis, I want votes. Okay, this is going to show me how many votes were cast total for Republicans in any particular year. Year X, Y votes, make it a bar chart. This is going to go away. I'm going to run it. And this is what you get. This is what we're working on. I ran this command, and I got this black and white bar chart, or grayscale. Okay, black and white, grayscale, call it whatever you want. This is the bar chart. I can look at this, and I can say that in the year 2010, there were approximately 35 million total votes cast for Republicans running for Senate. In the year 2016, there were a little over 40 million. Okay, because there were more voters and there were more Republicans up for election in big states, Texas and Florida and the like. Okay. And I could go look in the logbooks and see who it was and, and say, oh, this was this particular person or what have you. This is what you get. If you're not getting this, we need to figure out why. I know I've talked to a couple of you. One of the concerns I have is you're trying to get this to work with a 2D list. You can make it work with a 2D list, but it's ugly. If you're getting something that doesn't look like this, make sure that you are including, let me get the right one, this statement. Make sure that you are converting your 2D list to a data frame. Okay. If you're not converting it to a data frame, if you're trying to use a 2D list, we're going to have to do a lot more work. Make sure you have this statement inserted. Up here, you read in a data frame. That was the whole big thing. You converted it to a 2D list, right? That was in the assignment. You have to do this, right? Now you did your Python programming to work with your 2D list. Cool, we got it. Okay. Now we had to convert back to a data frame to use plot9, to use ggplot. This is how I did it. All right. I used the pd.dataframe, converted it back to a data frame. I assigned the column headings. I just showed you could either do it this way or that way. If you don't define the column headings, you're going to get 1, 2, 3, 4, 5, and 6. Actually, 0 through 6, I think. And then this statement is not going to work properly. So make sure you got the right column headings. So when you've got this year and votes data frame, this has to match this. It is case sensitive. If you're getting problems, make sure that this is exactly the same string as that one. It is case sensitive. You're going to have to make sure that matches. You could put the aesthetic in the geom col. I'm not going to show you that right now, but it could work. It's in the documentation. Remember that all the documentation for plot9 is right here. plot9.readthedocs.io. If you have any questions about how it works, that's the documentation. You can quick look up, or you can do a Google search or whatever for more information. This is the basic command, and that produces the bar chart. Now, that's not particularly informative. Okay, this is not a useful graphic. I want useful graphics. The whole point of Project 3 is to show how your Python programming skills help you in producing useful things, useful research results, and reporting them in whatever your major happens to be. So let's make this a little bit better. And what we're going to do is I'm going to say, in addition to the x-axis being year and the y-axis being votes, I'm going to say color equals state. And if I don't spell state right, it won't work. I'll get an error message. So let's just change it to color equals state and see what happens. Now, color equals state. This takes a minute. There we go. And now the nice thing about plot9 is it gives me the graphic. It tells me what color coincides with what state. This is really a little small, but if you blew this up into some ginormous thing, you could see that each of these columns is now marked off, and you could actually go into each column and figure out how many votes came from California, and how many votes came from Texas, and how many votes came from Ohio. And so therefore you can provide some color and information to your chart. Okay. We won't go into the details, but if you want to play around with it a little bit, you can tell plot9 to make state a factor. That changes this graph a little bit. Okay. Takes a minute or two to run. It doesn't change it a lot, but it changes a little bit. But I'm looking for something like that. So, bottom line for this part of the programming project, Make sure you read in your data frame. Make sure you convert your data frame to a 2D list. Then you do your programming to pick out the records you want. I showed you how to do that with just this simple little bit of code. That's all the Python it took to take that enormous initial file with 3,400 rows and change it into something where I got just the Republicans and just the columns I want. Okay. And so from that, I can start producing these bar graphs. A lot of people have asked, a number of students have asked, and we tried to work through it. In particular, I'll help find any bug I can. But the things to watch for, again, generically, make sure you are working with a data frame. Make sure when you run this, you are not working with a 2D list. Make sure you are working with the data frame. Okay. Now, another thing, this is just another way of fooling around with the same data. I played with it by overall data set. Let me delete this cell. I don't want that anymore. I don't need that. Talked about that. Okay. This I don't want. This is how to fool around with data frames. We're not going to get into this. We're not going to get into this. We're not going to get into that. What I want to do is move on to the states. I just have to cut a bunch of this junk I played around with. Okay, now, what I want to do is for the next part of the program, I want to deal with just the people, for Republicans, Democrats, what have you, in the states of Maryland, Virginia, and Pennsylvania. So I want to go through and do the same thing. I want just the columns I want, but I want, I'm going to cut that because that's the cheating way to do that. I'm going to show you how to do that. I want just the people from Maryland, Pennsylvania, and Virginia. I'm going to go back to my original DF. DF is my original two-dimensional list. Remember that lists are mutable. I didn't want to fool around with it, so I made some other things down here. Now I'm going to copy my same things. I'm going to start with this. I'll show you the code as I edit it. And we will hopefully get this to work first time, okay? States are Maryland, Pennsylvania, and Virginia. The same columns that I care about are the same ones. I'm going to call my brand new list MVP, Maryland, Virginia, and Pennsylvania. Here is what I'm going to do. I'm going to go through my initial entire data frame. Instead of checking to see if the party is Republican, I'm going to see if the state is equal to Maryland, or if the state is equal to Pennsylvania, which I can never manage to spell correctly in the same time, or it's equal to Virginia. Okay, what this does is it tells me I'm only going to want the people who are from Maryland or Pennsylvania or Virginia. And those I'm going to put in to my MVP list. Okay. Now, I probably have a typo in there, even though I did practice this 2 or 3 times before we started. But let's go ahead and run it and see what we get. Okay. It did not give me an error, so let's insert a cell, or let's go ahead and run MVP. It appears I now have an empty list. Let's see. What did I do wrong? Let me check up here and make sure I've got the state capitalized. Oh, because I'm being silly. Never mind. Here is exactly what I've done. Again, it has to match exactly. That was done so I could do this a different way. No wonder nothing matched. Okay. Because remember, I've taken just the state code. Now let's run this one. Okay. This actually works. I have all the people from Maryland, Pennsylvania, etc. Maryland, Pennsylvania, Virginia. Another way, the reason I did this is another way of writing this. If I comment this if statement out, I'm going to replace it. I can say if DFI state in states, and that should produce the same list. Either way, two different ways, Python programming. I now have just the Maryland, Virginia, and Pennsylvania. Now, since I went back to my original list, I went to my original 2D list, I don't have just the Republicans and Democrats. I have everybody. So the way I can do that is and df, I'm going to define parties equal the list Republican and Democrat, and I believe this is all lowercase. Yep, it's all lowercase. Okay. And DFI party in parties. Now let's run that. See what I've managed to horse around with. Now let's run that. Okay. Now we can look at our list and we can see we have a 2D list that consists of only people from Maryland, Virginia, and Pennsylvania who are Republicans or Democrats. That's what I want to do the next part of this problem. Okay. So again, I'm going to get rid of this cell because I don't need it anymore. I'm going to get rid of this cell because I don't need it anymore. Okay. Now I do have to, sorry, that's one below. Where am I? I do have to convert back to a data frame. Okay. I have to convert back to a data frame before I can use Plot9. And so the way I'm going to do that is new MVP, just because it's a silly name and I can't think of anything else right now. And I happen to have the code written that way. Pandas, data frame from MVP. And again, I want to tell it the column heading. Year, state, candidate, party, votes. And again, I have to spell it right. So now let's run that. And then just to show what we've got, I'll just do the head command, which just prints out a first few of these elements. Okay. And where did I make the mistake? Dot head is where I made the mistake. And now we can see that I have, in fact, a data frame, Republicans and Democrats, Maryland, Pennsylvania, Virginia, and number of votes. So again, this is just a test. This little bit of voting was all it took in your Python to start from that original 2D list and get down to a smaller 2D list. That's all I care about. Once I have that, this is what it took to create the data frame. Now that I have a data frame, I can start playing around with Plot9. I can start using ggplot to do a bunch of interesting charts, or what can I consider interesting charts? This line, as I said, just shows you what's here. So from Plot9, again, I should have this already, but I'm going to import it again just to play it safe. Doesn't hurt to import something multiple times. Create a ggplot object from new MVP. My aesthetic. I'm going to have the x-axis be year, and I'm going to have the y-axis be votes. I'm not going to go with state yet, and I'm going to have the color be party. So I'm going to get different lines for Democrats and Republicans. So let's run this right now. As you can see, it takes a while to run. Well, this is not a particularly useful thing, but okay, it's a start. These are line graphs. These are graphs that shows how many votes. This is just from Maryland, Virginia, and Pennsylvania that each party got in each particular state. And the chart over here, the legend, Plot9 tells me this, shows me that the blue is Republican and the brown is Democrat. Well, what if instead of party, I wanted to say state? Let's draw this same diagram, but let's have the color represent state. Okay, it takes a couple of seconds. Now I can see where the Maryland votes are, I can see where the Pennsylvania state's votes are, and I can see where the Virginia votes are by color. When the votes go down to 0, it means simply there was no Senate election in that state that year. Okay, so for example, 2020 happened to be that. In 2020, neither of our United States senators in Maryland was up for re-election. There were no votes cast for U.S. Senate in Maryland in 2020. Okay, we didn't get 2020 in this chart, but 2010 is that. We can see how these votes look, and Python is drawing it. Well, I still don't have it broken out by party, so let's expand this a little, and let's group by party. And again, I have to spell it right or it isn't going to work. And let's run it. And now I get a little bit more messy line, but I can see again by state which is which. And then if I start breaking this down, I can start getting by party how many Republican and how many Democrat. Okay. So the ideas for Project 3. You read in the file as a data frame. You convert that data frame to a 2D list. You filter the data frame, you filter the 2D list so that you have only the particular parties and only the particular states and only the particular people that you need. When you are ready to graph, when you are ready to draw your lines, your charts, you convert back to a data frame, and this is how you convert back to a data frame. And then you can run your graph on your data frame and you can start interpreting and you can start drawing things and adding your analysis. We showed how to do that for just the political party. This is how we did it to just get the Republicans. We showed how to do that for both state and political party. This is how to just get Maryland, Pennsylvania, and Virginia, and just get Republican and Democrat. Remember, for the actual project, you still got to get those two independents who won, and of course, you need other states as well. Now, the last step in the assignment says, I want you to, in addition to doing those two, and this last step is only a few points, don't worry. The bulk of your grade on this assignment is what we've shown so far. The last few points that are between perfection and just really, really good says, I want you to use your own imagination and be creative and draw additional charts, showing me things that are interesting that you have found from your data. Now, if you go over here to the Plot9 documentation, you can see some of the other documents you can draw. You can draw a scatter plot using geom_point. Okay, maybe a scatter plot is interesting because maybe a scatter plot of the actual, instead of trying to draw a line, okay, let's go back over here and just for the heck of it, in this step, instead of trying to draw a line here, what would this be if I wanted to make it a scatter plot? I don't want to draw lines. I just want the points. Now, I may have an issue with some of this. We'll fix it in a minute, but if we read it, yeah. Okay. It's not defined because I didn't import it. Okay. This is a scatter plot. This may be more interesting than the lines. So maybe you want to look at that. And maybe you want to add some documentation that tells me what this means. You can look at the state. Here's the deal. In any particular state, when you have two dots in the same year, you know what that means? One of them's a Republican, one of them's a Democrat. And you can look and tell me who it is. You can tell me whether this point, the scatter plot, adds some things. Okay, that's a scatter plot. Let's look at documentation and come up with some other things. It shows you all of the things you can draw using Plot9 and how you do it. Okay, a two-variable bar plot. This may be interesting for you because this shows you how to do multiple variables on the same plot. And maybe this is a good way to represent, Republican versus Democrat in those three states is in a multi-bar plot, and you just do it this way. Okay, so this is an example of multi-bar plots. Maybe that makes the geom call a little bit better. Look at some of the other things you can do. We probably don't want to get into political territories of Westeros. I showed you that before. We don't want to get into it. But step 13 is only a few points. Don't worry about it. Worry about it last. You'll probably get a 185, 190 out of 200, even if you don't try step 13. But all I really want you to do is come in here and look at this and say, which of these charts that are available to me in Plot9 are useful, that might give me some hints, or that might help me explain to my professor what this data means when I'm using this to do a research report in chemical engineering, or to do a research report in music theory, or to do a research report in American history. Okay, that's all I wanted you to do in the last step, step 13, is play around with Plot9 and do some additional interesting charts and tell me what you can learn, what you can do with it. So let's see, something in the chat. Okay. Different things. Yep. Let's see. If we do different things, that's useful stuff, good stuff. Okay. Yeah, same line graph, that's fine. I'm going to be happy with that. What I'm going to be happy with is the fact that you looked at this, you dug into it, and you learned different things, and you came out of this with a better understanding of how to use the tool, and your Python programming to do this. That's the whole point of Project 3. If you were in the major section, right, you would be doing all your game programming and writing your games and making cool games, and I will never criticize that. That's a neat thing. You would be doing more heavy-duty Python programming, but you would be, doing game stuff, as opposed to, in this case, what we want you to do is, show that you can use your Python programming to prepare research analyses in what you're doing. That being said, what I want to do, since I've already used up over half the class, is very quickly go through the sample final. Now, with some minor changes, this sample final was the final I gave in this class last semester. It was the spring 2020 final exam with a couple of minor changes. So there's a couple of things I'll go through and tell you not to worry about them too much, but I do want to go through this very quickly. So
Professor,
we'll do this. Yeah, go right ahead.
very quickly before we start that, can
Yep.
you do a quick demo on how we should submit the project?
Sure. I'm sorry. I put this announcement out on Blackboard this morning, but what it should be is I want your IPython. So let me go into Docs, Google. Doc. So what you do is your file on your laptop is something like project3.ipynb. IPYNB is how it ends. Okay. So I want you to move that to GL. In most cases, that's going to be SCP, secure copy. We've been talking about SCP all semester. If you have a question at SCP, let me know. But typically, you're going to use SCP to move it to GL. On GL, you should run the submit command. Submit. That capital S, it's small. CMSC 201. This is aggravating me. Project 3 in all caps. Project 3 is all caps. And then it will be, if we assume it's project 3.ipynb. That should do it. I'll monitor tonight to make sure. I do have a couple of errands to run, so I'll be out of pocket for about an hour, but I'll be checking tonight to make sure that works. That is what you should have to do. Move it from your laptop to GL using SCP, secure copy. On GL, run the submit command, submit CMSC 201. Project 3, all caps, is where you're going to submit it to, and then it's probably going to be called project3.ipynb.
One more thing, how do we secure a copy again? I don't think I've done that. I don't know.
Okay, are you on a Mac or Windows?
Mac.
Use your terminal.
Okay.
Bring up a terminal and type the command, and it's SCP, and then your user account. Hang on, let's see. Let me real quick share a terminal. Okay, I need a new terminal. Okay, and it's SCP. In this case, it's your user ID at GL. This is the easiest way to me. .edu. And then you'll give a file name. This probably won't work right because I don't know that I'm in the right directory, but you'll have the directory, you'll have the project right here or something, similar. It's this command. And then you'll be asked for your, I'm just going to randomly pick a file. Okay. So it's SCP, my username at gl.umbc.edu. And I'm going to send up March 30 coding.py just because that file exists. Now, commands in the right in the other order. To Arsenal. There we go. Okay. And it'll come back and ask for your password, and then you move it. I'll have to look at the exact syntax on the thing. Hang on. But yeah, just look up SCP on the terminal. It's a command on your Mac, and that will move it. If you're in Windows, there's a graphical user interface for WinSCP that's actually a whole lot easier. So
sounds good. Thanks.
Okay, I'll check at the end. Yeah, just look up one of these. Okay. Let's see now. What did I want? Okay. Here we go. Let's go back to the sample file. Let me go through this one. We should have time. I put an announcement also out in Blackboard. I should have announced this last week, but the course evaluation questionnaire is open. You have until midnight tomorrow night. I appreciate any constructive feedback. Constructive can be positive or negative. Anything that will make the class better for students next semester. I will be teaching this section again next semester. Anything that makes it better for the students is useful and appreciated, whether it is positive or negative. I really do mean that. So if you have a chance, go ahead and do this. Now, as I said, this was last semester's final with some minor tweaks, and I tried uploading it. Rather than typing it in on Blackboard, I uploaded it from my Mac, and it put some interesting strings in here, so let me fix this out. But at any rate, so if I have a string S equals double quote, Berkeley Blue, what's the result of printing the string S colon to 4? Remember that when we do slicing, when we do substrings, if there's nothing before the colon, we start at the beginning. And 4 is the one that we do not print, so we go from elements 0, 1, 2, and 3. Okay? And so that's a typo. The error, the value for the colon can't be blank. That's false. If that's blank, it just means start at the beginning. The answer to these, and with all the colon things, is this one, the 3 letters. Is what it's supposed to be. For some reason, a whole boatload of extra quotes got put in there. I will make sure that doesn't happen on the actual final. Point of that question is the substrings. If this is blank, that we start at the beginning, and we do not include 4. 2, the scope of a variable is all the places of the program, the functions and the main program where the variable is defined and can be used. That is true. That is what the scope means. 3, which of the following is not a good reason to use functions in your Python program? The answer is functions help your Python program execute faster. Functions have not necessarily any impact on how fast your program runs. They may be faster, they may be slower. So that is the answer to question 3. All the others are good reasons to use functions. You don't have to write the same code over and over. They can be imported. We've talked about importing functions that you write in one program into another program you or your classmates wrote. You can import them. That's true. They provide structure. They make bugs less likely to occur, and they make them easier to find. So all of those first 3 are true. The correct answer to question 3, the one that is not a good reason, is it executes faster because it may or may not actually do that. Okay. Question 4, given A is this hexadecimal number, 0xFF14, which of the following statements will cause the binary equivalent to be printed out? The answer is this one, A, the first one, A. Int converts it to an integer. Bin converts it to binary. I didn't have to have the int in there. I could just say bin of x. That would also have been an acceptable answer. Print X doesn't work, doesn't give you binary because you've got a hex. Print hex, it's already hex. You're not going to convert hex to hex. I mean, you could, it just doesn't give you what you wanted. And print int of X just converts it to an integer. So the correct answer for 4 is this first one. 5, operator precedence, logical operators and or not have higher preference. Boy, I couldn't spell when I was typing this in. I'm missing an H. They're done before the comparisons greater than or equal, less than equal. This is false. That is exactly backwards. And or not have a lower precedence. They come down toward the bottom. 6, how do you instantiate a new empty 2D list? Boy, this doesn't come and work out. L, the answer is this one. These are supposed to be square brackets. Interestingly enough, it sort of Blackboard ran them together into a box, but hopefully you can figure out in an actual thing. We instantiate a new 2D list with just a single set of brackets. It's instantiated the same way as a 1D list. The curly braces are a dictionary. The parentheses isn't anything, and we don't need the double blank double empty square brackets. Binary to hex. Remember the easy way, 4 binary digits equals 1 hex character. 1111 is an F. 0000 is a 0. So it has to be this one because it has to start with F and the next character has to be 0. You can check, certainly good to check. 1010, yep, that's an A. It's 10. 10 is an A. And 1101 is indeed a B. So it's 0x, meaning hex, F0AB. Binary to hex, 4 binary digits, 4 bits is 1 hex character. 8, we really didn't cover this semester, I realize, so don't expect a question like this on the final. The answer to this one is actually false. It doesn't look to the symbol table. The symbol table tells you where each variable is located in memory. It's called the calling stack, and there's actually another question on it. So Python looks to the calling stack to figure out where to return to, not the symbol table. This is false. But I doubt I'm going to throw that one on your exam because we didn't talk about it enough. 9, when printing to the screen using the Python print statements, only strings can be printed. You cannot print a float. This is false. This is false. Printing to the screen. Printing to a file, this would be a true statement. This would be a true statement if you're printing to the file, but printing to the screen, you can write floats and ints and things like that. So that's false. Which of the following types in Python is mutable? The only things we've talked about that are mutable are lists and dictionaries. Lists isn't here, so it must be dictionaries. Strings, floats, and integers are immutable. Dictionaries and lists are mutable. 11. If a list of data is not sorted in any particular order, which search strategy works best? If the list is not sorted, you must use linear. It's the only thing that works. That's why this is the correct answer. There really is no other option. Binary search will not work because that's not a sorted list. You don't know which way to go. And quicksort and insertion sort are not ways to search anyway. They're sorting algorithms. So the answer was linear search. There's really no other option. 12, what must all recursive functions have in order to be guaranteed to complete? A and B both. Okay. You got to have at least one base case, and you got to have at least one recursive case, and your recursive case has to simplify the problem. Your recursive case has to make it closer to a solution than the original, otherwise you're in an infinite loop. So the answer to this one is both A and B. Recursion requires a base case. Recursion also requires a recursive case. 13. If you write a Python program, p.py, that includes a function called getFile, your friend can include the statement import p in her program and the function, and then use the get function getFile. The answer to that is true. It's one of the advantages to importing modules and packages and libraries in Python. You write a program. It's really cool. It's got some cool functions in it. Your friend can import those and use them and not have to write that herself. Okay, that's true. It's key to Python. What does big theta indicate? We talked about this very briefly. Big theta means that the worst case and the best case are approximately the same. Okay, the best cases and the worst cases are the same, and big theta is that same. It's what they are. Big O is the worst case, as we've defined it. Big omega is the best case. If omega and O are the same, that's big theta. 15. Explain the difference between opening a file for writing with W and opening a file for appending with open A. Here's what I want. Opening for writing deletes any existing content. You start with a blank file. Opening for appending keeps existing content. You start writing at the end of what was there. In other words, you start appending to the end. That's what A is. Any other way of explaining this is acceptable. That's the idea. Opening for W, delete anything that was already there. Opening for appending, don't delete, keep it. Add on. 16. Sorry, just checking my time. Still good for now. Write a Python function that takes two integer parameters, height and width, and create a 2D list with height rows and width columns, and each entry has the sum of its row number and its column number. Fairly simple. Just don't have to write the main program, don't have to write the whole solution, just the function. Okay. Def, to define a function. Test problem takes two parameters, height, width. For I in range height. For J, I skipped one, hang on. New list is a blank list. For J in range weight. And we just talked about this again. Adding rows. Temp is going to be my 1D list. Temp dot append I plus J. Okay, what does I plus J do? I is the current row number. J is the current column number. So I plus J is the sum of the row number and the column number, like we had right here. That's I plus J. And I'm going to append that to a row. And then at the end of my row, I'm going to say new list dot append temp. I'm going to add that entire row, and that's all I want. The instructions did not say you have to return it, but if you want to include a return statement, that would be fine too. And I'm going to presume these indentations line up properly. I was trying to count spaces. That's what you need. Function. As with all other exams, you only have to include comments to help me. I will be grading these. You only have to include comments to help me understand what you meant. Okay. So in this case, I created a new list. I created for 2D. I created a 1D list so I can build a row at a time. I just add the row plus the thing that I needed, the row plus the column. And then when I had a row built, I added the whole row to the 2D list. And when the whole thing was done, I returned the list to the main program. That's all I need. 17. Define an algorithm, explain how an algorithm with big O n squared and big omega of n can sometimes run faster than an algorithm with big theta of n log n. Well, big omega of n means in the best case, I only have to go through once. Like, for example, bubble sort, if the list is already sorted, I only have to go through once. And then I can stop. Okay? So basically, I have to look at n different items. That's, big omega of n. Okay? Quick sort, which I've talked about, or some algorithm that's O of n log n, that's big theta, best case. Big theta is best case and worst case are the same. So if another algorithm n times the log of n, that's the best case, and n is much faster than n times log n, which you can see because the log of n for anything realistic is going to be, it's a number that's bigger than 1. Okay. The log base 2 of anything that we're talking about, where n is a an integer number of elements in the array, this is bigger. So that's what I'm looking for there, is the fact that what I'm looking for is an understanding that big omega means best case, and in best case you can have this better than this. Big theta, again, best case, and so n is faster than n log n. 18. Want a dictionary whose keys are the 5 American League East baseball teams, the Yankees, the Red Sox, the Orioles, the Rays, the Blue Jays, and the values associated with each key are the number of games each team lost in the 2019 season, which was the last actual season we actually had, which were in order. The Yankees lost 59, the Red Sox lost 78, the Orioles rose to glory and infamy with 108 losses. The Rays lost 66. The Blue Jays lost 95. So we're going to call our dictionary AL East equals dictionary string values Yankees colon 59 comma Red Sox, it's a string, so the blank spaces don't hurt us, has the value 78, comma. Orioles have the value 108, comma. Rays has the value 66, comma. And the Blue Jays has the value 95, and then close curly bracket to end our dictionary. I hit the wrong key there, sorry. There we go. And so that's what I'm looking for here. And it's an open book test. You can look it up to see whether there's colons or semicolons, whether there's commas or whatever. But that's just basically how to define a dictionary. Now, 19. Why do keys in Python dictionaries have to be unique? What would happen if in the previous dictionary I had Baltimore 3, Baltimore 6 as key value pairs? The answer is we would search the dictionary for the value to associate with the string Baltimore, and we wouldn't know which one to use. So, You could pick the first match. You could pick the last match. You could generate a random number. And pick that match. None of these is any good. Okay? None of these is a good idea. And so because if multiple ones were allowed, we would not be able to predict what happened. The bottom line is it's easier to say not allow multiple values, occurrences of the same key. That's the easiest thing to do. Now, of course, the occurrence can be a list. A key can map to a list and have the list as a value. That's fine. A key can even map to another dictionary and have an entire dictionary as a value. That's fine. So you can have multi-valued values. You can have values with more than just a single integer, but you cannot have the same key occur multiple times because you just would not know which value to pick. Okay, you don't have to worry about question 20 because we just didn't cover it this semester. I realized after the fact. The call stack, for future references in any other computer science class you take, is the data structure that keeps track of what function is executing and where the next instruction should come from. So in other words, that's the place where Python goes to say, I've executed this statement, what comes next? I've executed the return, where do I go from here? I've executed the, grade plus equals 3, where do I go from here? That's all kept in a data structure called the call stack. And that's the answer I was looking for question 20. But again, we didn't really cover it this semester for whatever reason. I guess I just didn't get to it that day. So you don't have to worry about a test question on it, but that's what the answer is. 21. If your program expects a function to return a list of strings, and when you run your program, your next statement results in an error that says, another typo, none type, not iterable, what happened? And the answer is that the function returned none. None is the value of none type. Okay, so your function returned none. You might not have had a return statement. Your return statement might have been an if clause that didn't get executed. Or you might have not expecting it to execute. For full credit on this question, I would accept your function returned the value none. You could go on to explain that possibly that means there was no return statement. Possibly that means you had a return statement that didn't get executed. Whatever. But for full credit, if you said the function returned none, that's good enough for me. Now, 22. Suppose you have a string representing course letter grades. It's comma separated. Everything is separated by comma. Write a Python function cleanup that reads in the string, takes the string as input, and returns a string with the grades separated by one blank space. Hint, use split and join, okay? So we'll say comma string equals input the current grade string. Okay. That's what we mean by taking the string as input. Someone will then type it. Oh, I better fix that typo. That's not a colon, that's a quote. Okay. So now my comma string is in the value comma string. Now I have to split it. I can split it and join it in the same statement. Python's nice that way. You would get full credit if you gave me a correct statement that included split and join in the same statement. But I'm going to break it up into a little bit. I'm going to say that my temporary list equals comma string dot split on the comma. Okay. So now I have a list of strings. Each string has one letter. And now I'm just going to join them. And I'm going to call it space string equals blank space dot join temp list. Okay. And now I'm going to return space string. And that is the code that would do what you wanted to. Okay. And yes, if you want to get geeky about it, you can combine the split and the join all in the same one, and it would actually work. But this is easier to me to understand. Okay. So that's what I'm looking for here. Just, remember how split works and remember how join works. Remember, split takes a string and gives you a list. Remember, join takes a list and gives you a string. You cannot put just the string right here. That won't work. You have to recognize that this is a list. Now we're out of time and I'm getting into write Python. So I'll put out answers to examples to question 23 and 24 and 25. They're fairly straightforward and you can do them, but I'll put acceptable answers to those on Blackboard when I get a chance. So that brings us to the end of the day and the last lecture. Remember, 3:30 to 5:30 next Monday, the 14th. If that is going to be a time problem for you, you need to let me know so I can figure out what to do and how to have you take it. It will be a Blackboard online test. It's essentially open book. I don't use the lockdown browser. You'll have 2 hours to do it. And then I'll get semester grades back to you as quickly as I can. And with that, as I said, you have until midnight. Make sure you submit something before midnight. Do not get to 11:59 and try to submit and realize it doesn't work. I will be monitoring Discord and my email off and on between now and then tonight. As I said, I unfortunately do have to run out and run an errand, so I'll be out for about an hour, but I will try to be there. That's pretty much it. Other than that, have fun. I will see you next Monday, and good luck to all of you. Thank you. Oh, and do your course evals.